Welcome back, people. 8th grade math class excitement. Today we're doing section 9.5, page 378, scientific notation. All right, let's do it. Page 378. Here we go. Okay, for it to be written in scientific notation, the number that you have at the beginning has to have only one number in front of the decimal. Here's my decimal. I don't know if you can see it. There we go. Okay, if this was 83 times 10 to the whatever, which is scientific notation, this would not be in scientific notation because this number, the decimal is not right after the first number. The way they explained it in the book is your number has to be between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and any of those decimals in between, okay? If it's not written in scientific notation, okay? So if you have to identify if it's written in scientific notation, first of all, look to see that the decimal is right after the first number. If it's not, immediately you can say, no, it's not written in scientific notation, okay? And your exponent here is always an integer. Whether it's a negative or a positive, it's always an integer. It's never going to be a decimal of some sort, okay, for it to be in scientific notation. So let's look at example number 1. Tell her whether the number is written in scientific notation and explain. Well, it's 5.9 times 10 to the negative 6. So my decimal is right after my first number. This is between 1 and 10, so we're good to go there. And this is an integer, so we're good to go there. So yes, it is written in scientific notation. If you have to explain, the directions say explain, say that you could say that the number is between 1 and 10, and the exponent is an integer. And that would be a good way to explain. Look at B, 1B. 0.9 times 10 to the 8th. Is this number between 1 and 10? No, right? It's less than 1. So this would not be written in scientific notation. The reason when you explain is because it is less than 1. What would you call that number? You could call it the factor. They call it the factor. The factor is less than 1. Okay? This number has to be between 1 and 10 for it to be scientific notation. Okay. So in scientific notation, another little quick clue is if you have a negative exponent, you're going to move your decimal point to the left. And if you, I know when you're watching me, that might not be left. If you have a positive exponent, you're going to move your decimal to the right. Maybe I'll turn around and that will work. Left if it's negative, right if it's positive. All right, so let's look at example number 2. All right, 3.22 times 10 to the negative 4 in standard form. Standard form means just a regular number that you're used to. One thing I want you to make sure you really know, because I know a lot of you don't do this, is please, please use commas. Commas. Use them. Okay. So we're going to take our decimal and we're going to move it 4 positions. We just have to decide if it's left or right. Well, remember, if the exponent is negative, we move our decimal to the left. So we move it 1, 2, 3, 4 positions, and empty spaces I fill with a 0. So this would be a 0.0000322 in standard form. Okay? One thing I kind of do to remember and make sure double check myself is if I have a negative exponent, I'm going to have a really small number. And I do. I have a small number, and so I must have moved it the right direction, because if it's a negative exponent, it's a small number. Okay, let's do B. Write 7.9 times 10 to the 5th in standard form. Okay, so we take our number and we're supposed to move it 5 positions. Remember, if my exponent is positive, I move it to the right. So here we go. 1, 2, 3, 4, 5. Fill in the empty spaces with the 0. And now, because I just told you to use commas, you're going to go ahead and put in your comma in the appropriate place so it's easier for me to grade. 790,000. Okay, so let's double check. If my exponent is positive, my number should be a big number. And it is. So we did it right. Perfect. Let's look at our next page. So far, so good, I think. All right, example number 3. An object with a lesser density than water will float. An object with a greater density than water will sink. Use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. In other words, is it going to float or is it going to sink? Well, I think probably most of us know that the apple's going to float and the brick's going to sink. But what you can do is you're going to turn them all into standard form so you can compare them, okay? So let's just do that really quick. 1 times 10 to the third is water, so that would be 1, and we're going to move it 1, 2, 3, so that's 1,000. Okay, then we're going to do a brick, which is 1.84 times 10 to the third. So there's my 1.84. I move it 1, 2, 3. Empty space gets filled with a 0. That's 1,840. Okay, and the last one we're going to do is an apple, which is 6.41 times 10 to the second. Okay, so here's 6.41. I'm going to move it 2 positions, 641. So we've turned them all into standard form. It's easier to compare numbers if they're all in standard form. So if you have to compare things, you want to put them into standard form first, and then it's really easy to compare. I can see that a brick is heavier than water, so it will sink, and an apple is lighter than water, so it will float. Denser. I meant to say denser, but I said lighter, sorry. Okay, so that's all you have to do when you are trying to compare. Turn them into standard form, and then you can easily tell which one's bigger and smaller. Okay, example 4. A dog has 100 female fleas. How many milliliters of blood do the fleas consume per day? Well, under the picture, because they always do this to you, information is under the picture. A female flea consumes 1.4 times 10 to the negative 5 liters of blood per day. Okay, and so we're going to take how much one of them does and multiply by how many fleas there are, which is 100. Okay, so they took and put 1.4 times 10 to the negative 5th in standard form, and then they multiplied it by 100. And you can use your calculator for that if you want. That's okay with me. All right. So I think that's it for 9.5. Hopefully it goes well. Good luck. Numbers 3 through 5. It looks like you're just going to be doing some multiplying and dividing. And then 6 through 14, you have to tell whether it's yes or no for scientific notation. And yes, please explain why. And then 15 through 23, you're just going to write them in standard form, which is the actual number like these ones. Okay, and then some word problems. So have a super fun time doing scientific notation, and I'll see you next time.